Today you'll need to learn how to use a separatory funnel successfully to separate the components of Goody's powder. You might have one of two types of separatory funnels in your lab drawer. You could have a glass stopcock, which has also a ground glass fitting. Needs to have a little bit of grease for it to be successful. When the stopcock is parallel to the direction of the flow, this is open, and you will lose everything that's in your separatory funnel down below. When it's perpendicular, it's closed. So take your separatory funnel out of your lab drawer. If you have a Teflon stopcock, it's got 4 components. You have a green or sometimes orange nut, a black O-ring, a white nut washer, and finally the stopcock itself. These need to be secure, but not so tight that you can't turn them. Again, when the stopcock's parallel to the sep funnel, you're going to lose everything that's in the sep funnel and it's going to drain out. When it's perpendicular, it's closed. So it's really important, whether it's closed or open, when you have your iron ring that supports it, first of all, you don't want it to fall down and through the ring. And second of all, you always want a beaker underneath in case you just screw up and forget and you leave this open. You just don't want to lose anything from that separatory funnel. You'll also need a stopper. The stopper is usually ground glass. It might need a little bit of grease, and it will fit into the top. When you first get set up, put your separatory funnel into the iron ring. You can leave the stopper off and make sure the stopcock is closed with the beaker underneath. To transfer your organic molecule from the aqueous to the organic layer, today you'll be using dichloromethane. Dichloromethane is a more dense solvent than water. As a result, it's going to be in the lower layer of your separatory funnel. When you add the dichloromethane, you'll probably notice that you don't have 2 miscible layers in your sep funnel. At this point, to transfer any material that's in the aqueous layer to the organic layer, you need to shake the layers together. Make sure to put the stopper on your separatory funnel and then remove it, holding it carefully. You need to keep the stopper in while you twist it upside down. Then you shake the funnel, pointing it away from your neighbor and away from anyone, and then you turn the valve so that it's parallel. That's called venting the separatory funnel. When you close again, shake and vent. You might hear the same noise. Close again, shake and vent. That's probably plenty. You don't need to shake super vigorously. You return the separatory funnel to this position, and you may be able to see the layers separate, but very important is to remove the stopper. Only when you've removed the stopper can the layers completely separate, and then the next process, draining the separated layers, can be done successfully. So you can see, hopefully right here, that we have a couple of layers. Sometimes a droplet gets stuck up above, and sometimes taking out the separatory funnel, shaking it a little bit, will help that last drop get down underneath the water and back with the dichloromethane. At this point, you can turn the stopcock so that it's parallel, although you want to do that slowly, and drain it into the beaker that's labeled organic layer. So if you go slowly, you'll have a pretty good separation. If you go too fast, you might risk getting some of the top layer contaminating the bottom layer. Once those layers are completely separated, you'll be able to clean up and make sure that you got all of the water out of the organic layer. But usually stopping the flow right before you get to the very end is one of the best choices because you make sure you don't get any water contaminating your organic layer. However, we don't completely remove all the water, and that's what the next step is about. How do we remove the last traces of water with a drying agent? To make sure we've removed all traces of water from our organic layer, even though we did a good job here with the separation, we use something called a drying agent. The one we use most often in the lab is magnesium sulfate. I have a little bit in a weigh boat, and in order to make sure I completely dried the organic layer and removed the water, I'll take a small scoop at a time, add it to my organic layer, and swirl. You might be able to see that there are some clumps which have absorbed the water, but also some kind of free-flowing sandy powder. That's exactly the kind of scenario we want. You can add a little bit more, but this is pretty expensive and you don't actually need to use very much to ensure that it's dry. As I added more, I didn't see additional clumps. I just pretty much kept the same sandy texture. So at this point, we would need a method to separate the solid from the liquid, which is vacuum filtration, and that's exactly what we're going to do next with this sample. Although you've done it before in a previous lab, here's a review of vacuum filtration. We use it to separate a solid from a liquid, and whichever piece of apparatus you choose depends on the situation. For a greater volume, you might use the Buchner funnel and the 125 ml filter flask. You also have a piece of filter paper you need to put in there. For today, though, we don't need anything quite that large. We can use the 50 ml or even the 25 milliliter filter flask, and this is the Hirsch funnel. So the Hirsch funnel has an adapter that helps it fit into the flask, as well as a filtering disc. If this has a hole in it, you need to exchange it, get a new one, because your filtration will not be successful. Fit it in securely, making sure not to break any glass or hurt yourself, and go to one of the benchtop vacuum outlets. You'll see that we have lots of hoses. Connect one securely to the sidearm, and at this point, you can't really let go of your flask. You need to hold on to it securely. The vacuum should have already been prepared by the lab tech, and you have your hose connected, so you can start turning on the vacuum. You'll need to turn the valve of the vacuum parallel to the hose, similar to the separatory funnel, in order to apply vacuum. You might hear a faint hiss, and if too many people are using the vacuum at once, it may not be very successful. So try to be patient and take your turns. Finally, to do the filtration, take your sample, swirl it so that you catch as much of the solid as possible, and pour it into the funnel. Again, you might hear a little bit of a hiss, and you've got your filtration complete. We had such a small amount this time. But very important now is to disconnect the hose first. So be careful and pull it off gently so that you now can hear the vacuum working. Then you can turn the valve perpendicular to the hose and turn the vacuum off. That's a filtration. If we want to remove the solvent, next we'll learn how to do evaporation with the vacuum in order to remove all of the solvent. Now to remove the solvent, remove the Hirsch funnel or whatever filter apparatus you used, and grab one of the septa with a needle or a piece of plastic hose stuck in it, and fit that securely into the top of your 50 ml filter flask. This will enable you to do vacuum evaporation of the solvent. Attach the vacuum hose again, and turn on the vacuum again so that the valve is parallel to the hose, and you might instantly see some changes in the appearance of your liquid. It's evaporating. It's also getting cold. And if that might cause a problem and it might quit evaporating because it's cold, you can use a warm water bath to encourage the evaporation to occur. It also might take a while if multiple people are using the vacuum at once. But as soon as you've finished with the complete evaporation of your solvent, sometimes even your hand might help warm it up so that it stays warm enough to evaporate. You would do the exact same process as for filtration. Disconnect the hose first, and if it's a really tight vacuum, that might be difficult, and turn the hose off, or turn the vacuum off so that the hose barb is parallel, or the hose valve is parallel. Once you've finished with the evaporation, you should have sometimes a solid left behind, and then you can continue with the rest of the experiment.